Hello everyone, today I'll be going through some useful summation formula that are very useful for things like Olympiads, especially the recent SMOs that happened, which is just past this past week, right? So let's look at this few identities that we have, right? So first is 1 plus 2 plus 3 plus 4 plus 5, basically the sum of all natural numbers until a certain point. And if you don't know, this is basically evaluated as, so if we plus all the way to plus n, sum is simply n times n plus 1 over 2, right? So try to remember this. So now let's look at the next formula. 1 squared plus 2 squared plus 3 squared plus 4 squared plus 5 squared, the sum of squares. And the identity for this, if we plus all the way until n squared, simply n multiplied by n plus 1 multiplied by 2n plus 1 over 6. Again, memorize this. And the third formula is 1 cubed plus 2 cubed plus 3 cubed all the way to n cubed. This one is actually given by n squared, n plus 1 squared, whole thing divided by 4, which you'll notice is actually this formula, but just squared. So if you want, you can also write it in this manner as well. Let's look at the last one, which is 2 to the power of 0 plus 2 to the power of 1, all the way to say 2 to the power of n. Right, first thing we have to notice is that 2 to the power of 0, an alternative way, not even an alternative way, but it's simply 1. 2 to the power of 1 is 2, 2 to the power of 2 is 4, 2 to the power of 3 is 8, 4 is 16, all the way to 2 to the power of n. This special trick only works for powers of 2, but you'll notice that actually, for example, 1 plus 2 is simply 4 minus 1. 1 plus 2 plus 4 is 7, which is 8 minus 1, dot all the way. So when you want to find the power of 2n, right, the formula here, the general formula is that 2 to the power of 0 plus 2 to the power of 1 all the way to 2 to the power of 2 to the power of n minus 1. I just need to add one more and I'll get 2n. Right, so this will be the formula that we can use here. Right, if you sub it into these examples, you'll find that it works perfectly well. And let's look at, this is not really a formula, but it's just a notation that SMO likes to use. Used in topics like calculus as well. It's called, this symbol here is called sigma, right? It's meant to represent what's called the sum. So when you see this, say I have k squared and the bottom is k equals 1 to 5. This basically means 1 squared plus 2 squared plus 3 squared plus 4 squared plus 5 squared. So it's the sum of this whole thing. That's what the notation means. It's very good if you memorize all of these identities because it's very, very useful for say Olympiads and all this. You can immediately solve questions. And if you're still a bit puzzled, let's solve some so you're maybe a bit clearer. This is question 2 from this year's SMO Open. But the difficulty of it, if you know these tricks, is really more of a SMO junior question. So let's see how we can solve this. Right, we're given that G1 is simply contains 1, 2, G2 contains 3, 4, 5, 6, etc. And the number of numbers in all of these sets, right? We see that they actually amount to 2. This one is 2 to the power of 1. This is 2 to the power of 2 because there's 4 numbers. This one is 2 to the power of 3 and there's 8 numbers. So the set Gn here contains the next 2n integers after the set Gn minus 1. So the question asks if S is the sum of all the positive integers from G1 to G8, find floor of S over 100. Before we solve this question, let me explain that the floor function, it's called floor function, it's about rounding down And where do we round down to? We round down to the nearest integer, right? So say if you have a floor of 3.5, and that's simply 3. If you have a floor of 4.9, that's simply 4. If you have a floor of a negative integer like negative 2.2, just look at your number line. So this is negative 2.2, this is negative 2, this is negative 3. We round this way. So it's simply negative 3. So without further ado, let's complete this question. You want the sum of all the integers from G1 to G8. So first you notice that they're actually going, it's the difference is 1, right? It's 1, 2, 3, 4, 5, 6. Right, so it's simply 1 plus 2, right, plus 3 plus all the way plus a number, but we don't know it yet. It ends at n. And we want to find this number n. Right, and you realize that, oh, if this has 2 to the power of 1 numbers, this has 2 to the power of 2 numbers, 2 to the power of 3, you realize that, oh, we can actually find n very easily. N is simply 2 to the power of 1 plus 2 to the power of 2, 2 to the power of 3, all the way to 2 to the power of, because there's G8 here, so it's 2 to the power of 8, we just need to find the sum. And we can simply use identity number 4 here to help us with this question. So we just need to add 1 here. So I'm going to plus 1, right? Plus 1 to this side. So, and when I plus 1 again, remember this actually gives me 2 to the power of 9, right? Which is 512. But that's not n, because I needed to plus 1 2 times. This is n plus 2. So we actually get n equals 510. So let's just sub it into this equation. And you realize that this question actually becomes very, very easy now, because it's the sum of natural numbers from 1 to 510, right? Simply, it's okay. You can have the formula for this, but let's just evaluate the whole thing, including the floor function. So the floor of s over 100 is simply n, right? N is 510. 510 plus 1 over 2 times 100. Let's evaluate this. Right, of course you can use like a few tricks and whatnot, cancel the zeros, things like that, but of course you have to do a bit of calculations in order to get the answer. We get floor of 1303.05, so we round down to 1303. That's the answer here. Let's look at the next question. SMO open, actually the Q3, so right after Q2. Tells us, again very easy, someone from junior can solve this if he has the right techniques. Let's look at this. A sequence of 100 positive integers from x1 to x100 are such that this sum is equivalent to 338350. Find the largest possible value of this expression, which if you listen to the sigma notation is simply x1 plus x2 all the way to x100. The trick for all these questions is that first we want to let your x1 be the lowest possible value, right? Lowest possible value, just to see how it behaves, right? So because we want to understand this equation. So what because this x1, all of them are actually positive integers, the lowest possible value they can get is 1, so why not let's sub in 1. So we get 1 squared plus 2 times 1 squared plus 3 times 1 squared all the way to 100 times 1 squared, which is simply 1 squared plus 2 squared plus 3 squared all the way to 100 squared. And you can solve this using the sum of squares formula. So it's given by n plus 1, which is 101, 2n plus 1, which is 201. And you take this, you divide by 6, that's the sum. Then you can perhaps do some sort of factorization, not factorizations, but simplifications, right? Maybe you cancel this out, becomes 3, 201 divided by 3, right, 201 divided by 3 is 67. When you evaluate this expression, 50 times 101 times 67, you'll find that, oh, this actually equals 338,350. And this is exactly the same as what the question asks us. Hence, we have concluded that our hypothesis is correct. Okay, so x1 equals x2 equals x3, right, all the way to x100. This is simply 1. Hence, the sum of all your x terms from x1 to 100 is simply 100. We have solved these two open questions using very simple identities. That's all for today. Thank you for watching.